Alright, in this video I'm going to be going through the exponent rules practice. In this activity I actually introduce a couple of new rules, just a couple of basic things that are just a little beyond what we've already done. And at the top here we're going to practice each rule, and then when we get to the bottom they're all mixed up and it'll give you some opportunity to practice the rules. Alright, so let's go ahead and get started. Alright, so first of all, the product rule is that one there. If you multiply two powers of a or some base, then you add the exponents. So let's go ahead and actually I'm going to go ahead and put all the rules across the top here, and for some of you, you may just want to do 1 through 20 and then you can see what I did. So this is the quotient rule. If it's true that when you multiply powers of a you add your exponents, then it makes sense that when you divide powers of a, you're going to subtract the exponents. So the product and quotient rules are basically opposite kind of rules, or opposites of each other. And we got the power rule, or I sometimes call it the power to a power rule, and that's the one where we multiply the exponents. And then we have the expanded power rule, which basically we have two numbers multiplied inside parentheses to some power. We can just take each of those numbers to that power. And the new rule, the first new rule that I'm going to add, basically is quite similar. It's just if you have a fraction, and you have a over b to some power, then you can apply that power to the numerator and denominator separately. So it's another one of our expanded power rules. So let's go ahead and get started. Again, I would encourage you to try to do 1 through 20 and then watch the video. Do as many as you can. Alright, so the product rule, basically all we're going to be doing here is adding our exponents. So we're going to get 5 plus 2 will be x to the 7th. And here we're going to get 5 to the 14th, because 6 plus 8 is 14. Now you got to be careful with these numbers. Sometimes students will write 25 as a base here, or something else like 10. But when you use any of the rules of exponents, the base never changes. On number 1, we had a base of x to the 5th, and x squared. And when we got our answer, it was x to the 7th. The base doesn't change. It never does when you use the rule of exponents. All right, on number 3, you got to be just a little bit careful there, because that's z to the first power, so when you add the exponents you get z to the 4th. Another way to think of this is if you have three z's multiplied, which is what z cubed means, and you multiply that times another z, then you have a total of 4 z's multiplied, which is what z to the 4th means. Alright, so look at number 4 now. In this case the bases aren't the same, so we don't have a rule of exponents for this one. This thing is basically already simplified. And then on number 5 you should have added the exponents and you get x to the 12th. Alright, then we get to the quotient rule, and again now we're doing the opposite. We're dividing two powers of x, so we're going to end up subtracting our exponents. So 5 minus 3, we're going to get x squared, y to the 13th over y to the 5th, we're going to get x to the 8th, 13 minus 5. Number 8, we get 2 to the 12th. Again, the base doesn't change, and 14 minus 2 is 12. Be careful with number 9. Any number divided by itself is 1. Like 7 divides 7, or 7 over 7 would be 1. No matter what it is, anything over itself is equal to 1. So this is equal to 1. Now if you use the quotient rule, your base would be z, and 2 minus 2 is 0, and so you would get z to the 0 power. So what we've really done here is we found a new rule. We see that any base to the 0 power, or at least that's what we're seeing here, z to the 0 power is 1. Turns out that that's true for any base. Anytime you take any base to the 0 power, you're going to get 1. Alright, let's look at number 10. That one's also a little bit different. So if you subtract the exponents, you're going to get x to the negative 3 power. Well, we haven't even talked about negative exponents yet. So let's approach this problem just a little bit differently. It turns out this is equal to 1 over x cubed. Let me show you why. So I could actually write out 4x's multiplied in the numerator and 7x's multiplied in the denominator. And so we can cancel the 4x's in the numerator with 4x's in the denominator. When we cancel, basically put that little 1 there, we're basically dividing by x to the 4th in the numerator and denominator. So we're going to end up with 1 over 3x's multiplied, which is 1 over x cubed. So as you look at this problem here, what I would say is let's use the quotient rule with an adjustment. We're still going to subtract our exponents, but since the denominator has the bigger exponent, after we subtract our exponents, we're going to put x in the denominator. So 7 minus 4 is 3, and so we're going to put that x cubed in the denominator since the denominator had the bigger number. So we don't really need to use negative exponents to do this problem. We can just do a variation of the quotient rule. All right, when we get to the next column there, we're dealing with the power rule. So here we're just going to multiply, whoops, let me finish this up. So we're going to multiply our exponents. So we're going to get x to the 8th for the first one, a to the 12th on the second one, 2 to the 12th on number 13, z to the 16th, and 15 is going to be y to the 20th. We're just multiplying our exponents on each of those. So we're going to do the same kind of thing when we get to this last column, except for we're also going to have to deal with numbers. And again, I call this the expanded power rule. So look at number 16. We're going to square negative 3, and we're going to square x. So we're squaring each of the numbers inside, the negative 3 and the x, but we're doing it separately. Negative 3 squared is 9, so this becomes 9x squared. On number 17, 2 to the 3rd power, let's see, 2 times 2 times 2, we're going to get 8. Actually, I want to write this one out. And then x to the 4th raised to the 3rd power. So we're basically cubing the 2, and we're cubing x to the 4th. And so 2 to the 3rd power is 8, and x to the 4th, well, notice it's raised, it's a power to a power, so we're going to multiply the 4 and the 3 to get x to the 12. All right, so number 18 and 19 work very similar to the ones we just did. So in the numerator on number 18, it'll be power to a power, so this becomes a to the 6th. And then we also in the denominator have to take 4 to the 3rd power. Now be careful how you do that. First of all, you don't multiply. It's 4 to the 3rd power. And so when we multiply 3 4s, we get 64. So our final answer is a to the 6th over 64. On number 19, 5 squared is 25. X squared squared, well, that's power to a power, so we'll multiply, we get x to the 4th. And in the denominator, we have y cubed squared, so power to a power, we multiply the exponents again, we get y to the 6th. On number 20, that's like the first two we did, we'll do x to the 5th to the 3rd power, so power to a power, we get x to the 15th, and we're going to get y to the 9th. All right, so let's go on to the ones where we have exponent of 0. So first of all, I already pointed out that any base to the 0 power is 1. Basically, we can use the quotient rule to justify that like I did up above. So any base to the 0 power is 1. The thing you have to be careful of with these problems is that you know what your base is. We've talked about this before, like if we have, if we have negative 3 squared, my base is everything inside the parentheses, so here we're multiplying negative 3 times negative 3, and we get positive 9. If you had a problem like this, negative 3 squared without the parentheses, this time my base is just the 3. So I've got to ignore the negative for now because we always will apply the exponent first. Order of operations would require us to do that. So we get 9, and then apply the negative. So in the first case, we get 9, and in this case, we get negative 9. So in a similar way, you're going to have to be careful with numbers 22 or 21 through 25. So you may want to try those and then watch the video. Let me go ahead and erase these. All right. Let's go ahead and look at these. So we know any base to the 0 power is 1, so that one was the easy one. Now be careful on number 22. The 2 is your base, and so 2 to the 0 power is 1, and then we're going to have to apply the negative to that. So again, the negative is not part of the base. Whatever you get when you take 2 to the 0 power, you're going to make that negative. Another way to think of it is you're basically multiplying 2 to the 0 power times negative 1. On number 3, or 23, our base is everything inside the parentheses. And so any base to the 0 power is 1, so this is 1. On number 24, it's x is my base, so x to 0 is 1. Notice we're going to have negative 5 times 1, so we get negative 5. And finally on number 25, my base is everything inside the parentheses. Any base to the 0 power is 1. And so that's what we're going to get here. All right, so now things are all mixed up. You're going to run into a few things that we haven't done before, but you have all the skills you need. It's just putting them all together. So I would encourage you to do as many of the problems as you can, and then watch the video for whatever ones you want to get some help with. All right, so let's go ahead and look at 26. Here we have a power to a power, so we're going to multiply the exponents. Power to a power rule. On number 27, that's a product of 2 powers of x, so we're going to add the exponents. Now number 28 is very similar. It's all multiplication. We have 2 powers of x that are being multiplied. Sometimes people will actually rearrange this. You can do that with multiplication because the order you multiply doesn't matter. So let's multiply our numbers together and let's multiply our x's together. We get negative 18 times x to the 4th. Don't forget that's an x to the 1st times x cubed. So you don't really need to rearrange the numbers, but if it's helpful, you can certainly do that. Now look at number 29. It's just a little different than any of the ones we've done so far. Notice the way I just rewrote it. Can I do that? Is that legal? Well, remember how we multiply fractions, we multiply across. So if I multiplied across, I would get what I started with. So I could do that. And 6 over 2, that's just 6 divide 2, we get 3. And x to the 9th over x cubed, we're going to use the quotient rule and subtract our exponents, we get x to the 6th. So be careful when you do these. When you're simplifying the 6 over 2, you're not using any rules of exponents. You're just simplifying a fraction. But when you deal with the x's, now you're using a rule of exponents. So be careful that you don't get those things confused. On number 30, the way I like to usually do these is I think of it almost like 2 different problems or 2 separate problems. 5/10, well, that's a fraction that reduces to a half. So let's go ahead and write a half there. And then, oh, we got a little problem here. So we're going to use the quotient rule, but look at the denominator. It's got the bigger number. So we'll do 8 minus 3, which is 5. But we're going to put our x to the 5th in the denominator. All right, on 31, let's see, that's that expanded power rule. We're going to take negative 3 to the 4th power times x to the 4th power. And if you multiply out 4 negative 3's, let's see, I'll do it right here. Well, here you get 9, and here you get 9, and so you are going to get 81 here. So let me erase my work here. All right, so we're going to end up with 81 x to the 4th. All right, on number 32, we're going to cube 2. That's 8. 2 times 2 times 2. X to the 4th cubed, so that's a power to a power. We'll multiply our exponents. We get x to the 12th. Y squared cubed, that's a power to a power. So we'll multiply our exponents again. So you might want to try 33 if you didn't already do that. It's just like the one we just did. All right, on number 33, negative 3 squared is 9. A to the 4th squared, that's a power to a power. We get a to the 8th. Now sometimes students will just write b next, but aren't we squaring the b? We're squaring everything inside the parentheses. So this becomes b squared. So 9a to the 8th, b squared. On number 34, we're using the other expanded power rule that we use with fractions. So we're going to take the numerator to the 4th power, or we get a to the 4th. And in the denominator, we're going to have 2 to the 4th. And you're going to have to multiply 4 2's. You end up getting a to the 4th over 16. All right, on number 35, 5 cubed is 125. Y to the 3rd power, make sure you put that 3 there. And then we have x to the 4th to the 3rd power, power to a power. So we'll multiply and we get x to the 12th. Number 36 is very similar to number 30. We're going to, again, I think of it as like two numbers or two problems in one. 18 over 6, that's division. You divide there, you get 3, or a fraction that reduces to 3. And x to the 6th over x to the 1st, 6 minus 1, we get x to the 5th. Similarly, we get negative 2 on 37. X to the 5th over x cubed, subtract your exponents. We're using the quotient rule. We get x squared. Now be careful on the y's, because notice the 4, or the denominator, has the bigger exponent. So 4 minus 2 is 2. But we're going to put that y squared in the denominator. Basically what's going on here is we have 2 y's multiplied in the numerator, and we have 4 y's multiplied in the denominator. So I could cancel out 2 of my y's in the numerator with 2 in the denominator, and I would still have 2 y factors in the denominator, which we would say or write as y squared. All right, number 38, very similar. 2/4 is 1, or 2/8 reduces to 1/4. Notice the y to the 4th power, the bigger numbers in the denominator, or bigger exponent. 4 minus 3 is 1. So we're going to put y to the 1st power in the denominator, but we don't really need the 1. You can put it, but you don't need it. And then z squared over z to the 1st, 2 minus 1 is 2. I'm sorry, 2 minus 1 is 1. And that z to the 1st power, though, that's going to go in the numerator. Now, in the final answer, you don't really need the 1 in the numerator. I don't care either way, but probably would take it out. I'm just going to leave it alone. Number 39. This is another one of those problems like 28. We're going to multiply our numbers. We get 20. X times x cubed, that would be x to the 4th. Y cubed times y squared. We're using the product rule. We're going to add our exponents. And similarly in number 40, we're going to get negative 36 when we multiply the numbers. A times a squared is a cubed, and b squared times b to the 3rd is b to the 5th. And that's it for this video.